Welcome to the video on cardinality. Throughout this video, we will understand what cardinality is and the things we need to consider when using highly cardinal variables to build machine learning models. We mentioned previously that the values of a categorical variable are selected from a group of categories, also called labels. This is, the values of a categorical variable are generally strings instead of numbers. The number of different categories in a variable is known as cardinality. In this example, the cardinality of the variable gender is 2, because gender contains only 2 labels, male and female. And the cardinality of the variable vehicle make in this table is 9, as it contains 9 different labels, which are Mercedes-Benz, Ford, Renault, and so on. Other variables like city or postcode can contain a huge number of different labels. They are highly cardinal. Let's talk about cardinality effects. What are the things we need to consider when working with categorical and highly cardinal variables? Are in fact multiple labels in a categorical variable a challenge for machine learning? There are a few things to consider when working with categorical variables. First, scikit-learn, which is the industry standard Python library for machine learning, does not support strings as inputs. Therefore, we need to transform those strings into numbers if we want to use this library. Second, highly cardinal variables may lead to an uneven distribution of the labels across the training and the testing sets, which may derive in overfitting, particularly in tree-based algorithms, or operational problems when we want to use those models live. As I said, scikit-learn does not support strings as inputs, and therefore we need to encode those categories into numbers. We can use a variety of categorical encoding techniques to do so, and these techniques may alter the feature space and also the interaction between the variables. I will say more on categorical encoding techniques in a dedicated section later in the course. When splitting into train and test set, some categories of the variable may land only on the train set and some only on the test set. If labels or categories land only on the training set, the trained models may end up overfitting to those labels. And on the other hand, if the categories appear only on the test set, the models will not know how to interpret that label, because they haven't seen those while they were being trained. For example, let's look at the variable vehicle make in this table. When we divide the dataset into train and test, we can see that some labels like Mercedes, Citroën, and Nissan appear only on the training set, whereas other labels like Seat, Toyota, and BMW appear only on the test set. Those labels that appear on the train set may cause overfitting, whereas those labels that appear on the test set may cause operational problems. Why can these labels cause overfitting? Variables with too many labels tend to dominate over those with fewer labels, particularly in tree-based algorithms. Also, a big number of labels within a variable may introduce noise with little if any information. Therefore, reducing the cardinality may help improve model performance. And why did I mention that labels in the test set may cause operational problems? Models learn how to make predictions using the information they saw on the training set. For those unseen categories, the models will be unable to perform a calculation. They will not be able to understand what to make of the new label, and this could end up in the return of an error instead of a prediction. So in summary, the key messages from this video are that strings need to be encoded as numbers if we want to use scikit-learn. High cardinality may cause overfitting and operationalizational problems, and reducing cardinality may improve model performance. There is an accompanying Jupyter notebook to this video, where you will find notes on cardinality and its effects on model performance and operationalization. You will also find code to quantify cardinality, examples of high and low cardinality variables, examples of the uneven distribution of the categories between the train and the test set for highly cardinal variables, and finally, the impact of cardinality on machine learning model performance. So don't forget to check this Jupyter notebook out. Thank you, and see you in the next video.